All right, so we are going to be going over triangle congruence theorems. And remember, congruent triangles are two triangles that have the exact same measurements, the same side measurements, and the same angle measurements. And the easiest way to check to see if two triangles are congruent is to check all the sides and all the angles. However, you don't need all that information. In fact, with some of these theorems, we only need some of the information of the triangles, of two triangles, I should say, to see that both triangles are congruent. One of them is called the side-side-side theorem, SSS. And that's literally the three sides of one triangle are congruent to the three sides of another triangle. That means side 1 congruent to side 1, side 2 congruent to side 2, side 3 congruent to side 3. And the nature of triangles pretty much tells us that as long as the three sides are the same, the three angles will be the same as well. We don't need the angles. We don't need the angle measurements here in order to show that the two triangles are congruent. As long as the three sides are congruent like this, these two triangles will be congruent. So there's side, 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 right over here. Also side, angle, side. That's two sides and an included angle. An angle in between the two sides. So that's going to be side 1, side 2, and an angle between them. If both triangles have two sides and an included angle marked as congruent, then the two triangles will be congruent based off of the side angle side theorem. There's a difference between an included side and a non-included side. The included side, or in this case the included angle, there's also included sides too, but the included angle is the angle in between the two sides. So that's side, angle, side. The angle is in between the two sides. We also have angle, side, angle. Two triangles can be marked as congruent if the two angles and an included side between those two angles are congruent. That means angle 1, angle 2, and an included side, which is the side in between those two angles. That right there tells us that those two triangles are congruent as long as the markings match with side, angle, specifically. Angle, side, angle. So we have side, 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 we have side, angle, side, angle, and then we have angle, angle, side. We can say two triangles are congruent if the two angles and a non-included side is marked as congruent. So that's two angles, 1, 2, and a side that's not in between those two angles. So that's angle, angle, and I'm going to mark that side right over there. Angle, angle, side. Those are the four main theorems that we use to show two triangles are in fact congruent. And in all of those cases, we don't need all the sides or all the angles. We are just looking at the 3 bits of information from both triangles. As long as for side, 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 it's triple S, SSS. Two sides, triple S, three sides, all three sides are congruent from one triangle to the next triangle. All three sides are congruent. For side angle side, SAS, that's two sides and the angle in between the two sides. Then we have angle side angle, ASA, two angles and a side in between, and angle, angle, side, two angles and a side that's not in between. So one of the things that we're going to need to make sure we're able to do on quizzes and tests is if I give you two triangles like this right over here, I'm going to come back to the notes in a little bit, but if I see two triangles right over here, it's going to be up to us to figure out, are these two triangles congruent, yes or no? And if they are, how do we know? So that's where we're going to use side, 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 angle, angle, and angle, angle, side. There's one more that we're going to talk about, and that's hypotenuse leg, only applies to right triangles. Hypotenuse leg, HL. Remember, the hypotenuse is always the longest side and one of the legs. Hypotenuse and one of the legs. For a right triangle, all you need is the hypotenuse and one of the legs to be congruent on both triangles, and the two triangles would be congruent. A couple of things to remember. An included side is the side in between the two angles, like this. And an included angle is going to be the angle in between two sides. Now, there are only two times when we can make markings. If they share a side, which is right over here, M and P, we have two triangles, both sharing the side right over here. It's the exact same side on both triangles. So that will not be marked, but you're going to need to know that that side is congruent between the two triangles. If they share a side, and also vertical angles. Vertical angles won't always be marked. But we know by now vertical angles are congruent. You won't see them marked though. Those are the only times we can add markings to a picture. If nothing else is marked on the triangle and we can't add any markings, we cannot make the assumption that the two triangles are congruent. We can only work with things that are marked. So right over here, do we know if these two triangles are congruent? Let's see. I got an angle right over here. I have the side right over here. And looks like I got 1, 2 lines crossing. That's a vertical angle right over here. 1, 2. And I'm going to mark that to show it's different from the other first angle. So that means I have two angles and a side in between the two angles. So are these two triangles congruent? Yes, they are. What's the reason why they're congruent? It fits the side, angle, side theorem. No, it does not. It fits angle, side, angle theorem. Very important, especially when you get down to a quiz or a test. If you put down the wrong reason, let me bring that. If you put down the wrong reason right over here, points off. This is angle, side, angle. Number 2. See what we have right over here. We have another 1, 2. We have another set of vertical angles this way. 1, 2. And we have another angle right over there. Angle, angle, and this side that's marked is not in between those two angles. Looks like we have angle, angle, and a side that's not in the middle. But that does fit angle, angle, side. And is that one of the ways to show that two triangles are congruent? Yes, it is. So that means, yes, they're congruent. And it fits the angle, angle, side postulate. Angle, angle, side theorem. All right. Number 3, another set of vertical angles. And remember, vertical angles won't be marked. So it's going to be up to you to mark them. So I got angle. I have two sides and an angle in between those two sides. Side, angle, side. So are these two triangles congruent? Yes, because of side, angle, side. Number 4. Again, right over here, another set of vertical angles. Got a lot of vertical angles on this sheet. Two angles and a side not in between. Two angles and a side not in between. That fits one of the categories. Specifically, it fits angle, angle, side. Remember, angle, side, angle is when the side is in between the two angles. Angle, angle, side is when the side is not in between the two angles. It's the non-included side right over there. We have 5 and we have 7 right over here. Now this time we don't have a set of vertical angles, but we do have this shared side right over here. You know, two triangles sharing the same side, so that side is automatically congruent. One angle, two angles, and a side that's not in between them. That fits angle, angle, side. So those two triangles are congruent because of angle, angle, side. Number 6, another one. Another shared side right over here. That's a shared side, an angle right over there, and another side right over there. Side, angle, side, side, angle, side. That is one of the categories. So this is congruent. These two triangles are congruent because of side, angle, side. Number 7. This side is marked as congruent. This side is marked as congruent. And we got this side right over there. That's being shared between the two triangles. So those two triangles are congruent because of side, side, side. And then finally on this on the notes right over here, number 8. This is a right angle. And if it's a straight line, we'll assume that's a right line right over there. So that's 90. This will also be 90. We got this right over here that's marked across from the right angle, and a shared side right over there. So since we got a right triangle, that opens up the possibility for hypotenuse leg, and that's what this is. Some books will actually say right angle hypotenuse leg. Hypotenuse leg will be fine for our purposes. So HL, the hypotenuse is marked as congruent, and one of the legs is being shared. So the two triangles are congruent because of hypotenuse leg. So when it comes down to proving two triangles are congruent, we're going to need to make sure that we're able to use these reasonings, these 5 reasonings. The hypotenuse leg is the other one. Only for right angles only. So you're going to need to be able to use them in the correct positions. All right. And that is the main triangle congruency theorems. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And hypotenuse leg, the special one.